Hello friends, and welcome to our channel Scientific Factory. So friends, today I'm going to prove that area of a square is half into square of its diagonal. That you can see right now. So friends, I've uploaded two more videos earlier. The first video I've uploaded about how to prove the area of circle is 2 as pi r square, and second one is how to prove the area of rectangle, that is L into B. So today I'm going to prove that how is it possible to prove the area of a square is half into square of its diagonal, because normally friends, what do we know that area of a square is side square. So today I'm going to prove that area of a square is half into square of its diagonal. So friends, let's see. This is a square. As you can see, ABCD is a square, and its diagonal is the line segment which joins two non-adjacent vertex that we can see. So friends, here D and C are adjacent and A and B and adjacent, but C and A are not adjacent vertex, and B and D are also not adjacent vertex that we can see right now. And friends, in square all sides are equal and we denote it by A, and diagonal is denoted by D. Now friends, let's move forward. Today I'm going to prove that area of square is half into square of its diagonal by using two formulas that you can see. Area of a square is side square, which we know normally, and second is that the Pythagoras theorem, which is applicable for the right angle triangle, that is a square is equals to p square plus p square. Suppose friends, if you take this as a right triangle, suppose this is a right triangle ABC, and this is right at A, then the opposite side to this vertex where right angle is formed, that is called the hypotenuse, and this is called base, and this is called the perpendicular. And if you tilt it, then it would also be called as a base, and it would also be called a perpendicular. But in case of hypotenuse will always be called the side which will be opposite to the right angle. So friends, now let's move. And before just proving, at first we must know about important properties that I'm going to use. That all sides are equal, that we all know. In a square all sides are equal and all angles are of right angles, that is about 90 degree. And friends, we know that there are 6 to 7 types of angles that we have studied in earlier classes, sorry. And the third property that I'm going to use, that is diagonals divide the square into two equal triangles. So that we can see friends, is here is ABCD as a square and BD is a diagonal. So it divides the square ABCD into two equal triangles, that is ADB and BCD. So its area becomes equals to the sum of ABD triangle and the BCD triangle as well. Because friends, in class 9 you'll get to know that how is it possible that the diagonal divides the square into two. So friends, it could be proved by using congruency criteria, that is S sides, and you can prove that yes, the diagonal of a square divides into two equal parts. Now friends, let's move forward towards proving. At first we'll have to find out the relation between the diagonal and the side of the square. Then we'll be able to find out that how is it possible that this area of a square is half into square of its diagonal. So at first friends, we am going to use that Pythagoras theorem, that is h square is equal to p square is equal to b square, and I have made you understand that what is called h and what is called p and what is called b. P is perpendicular, b is for base, and h is for hypotenuse. So friends, here hypotenuse in this example, here hypotenuse is diagonal. So friends, we use D in case of, and perpendicular is also the side of this square, and the base is also the side of the square. So we write D square is equal to A square and A square. So after is just moving forward, and after we move forward, so D square is equal to 2A square. We will add and we'll get 2A squares. Now D, if you take the square power squares to the right sides, we'll get root 2A square. So if we split 2 into A, so A into A is a perfect square number, so we take A outsides and root 2 and separately. Okay, so friends, now this is, and after that it's D is equals to A root 2, means diagonal is equals to A side of the square multiplied root 2. So if you take if you take just root 2 to this sides, we get A is equals to D by 2. So this is the relation, and that is term, and I have just marked it as an equation. Now let's move forward. So friends, now I'm going to use equation 1 in a normal formula finding a square, that is side square. So friends, we know that area of a square is equal to a squares. Now we have found the relation, and I'm going in equation A that you can see area of a side of a square is equals to diagonal divided by root 2. Now putting the value, and so friends, putting the value of a is equals to d by 2 as I have found it in equation and marked as equation way, that you can find that the side of a square is equals to diagonal divided by root 2. So friends, I'm going to put the value of a here. So here a square is equals to, which means d by 2 to the square. So d into 2 is equals to and d into d by 2 d by root 2 into d by root 2. So friends, as we know that when we just multiply one numbers, so every number have one power, and when we multiply, the power gets added, so it becomes t squares, and it becomes root 2 into 2, which is 4, which is a perfect square number. So we just take 2 outside, so we get t square by 2. So friends, and we can write as half into square of its diagonal. So friends, this is how we can prove that area of square is half into product of its diagonal. So I hope friends you like this video, and if you have liked, then subscribe and press the bell icon and get latest videos like this, and just I hope and share with your friends as well. Thanks for your precious time.